Oh. Don't use that.
No, it's 3.
No, you use 3. And it goes 5. You move it over to the other side. Because you're trying to do things that are unnecessary. Okay, well, hey, so I've heard a couple of you ask from what to what should we do the integral of, because in the 84, the only way you can do an integral is from something to something else, right? Has anyone figured out what your endpoints are going to be yet?
what's something 3?
Okay, something in 3.
Well,
Why 1? What is the integral from 1 to 3 of f of x? Using a fundamental theorem of calculus. I think y'all really see way too much effort. Right? What is that equal?
So if we get 6.58 block, then we equals minus 5 times
It's something that y'all have really forgotten. Like since last test, like remember the endpoint equals the start point plus the integral from start to end? Yes? So if I want to find g of 1, I could use that. Or I could use the fundamental theorem and rearrange. But either way, you need to be using one of those two things. You need to highlight that in your notes. I'm disappointed in this which part of it y'all didn't come in and start it. You gotta work on that. I'm gonna start writing distinctions in BC calculus. Oh my goodness, guys. Okay, so what do we get using a calculator? Why B? What did you get? How'd you do it? Okay, so this integral done in the calculator, correct? You don't have to do. In fact, can you do a U substitution? No. Why not? Right, there's no 3x squared on the outside or any x squared on the outside. If there were, it would be nice. We could do a U substitution, but you cannot. So you have to use a calculator to get this. You can subtract the 5 over and divide by -1. Is that what you did? If you use this option. Or you could rearrange the 1 and the 3. You've got a lot of options, but it hinges on a fundamental theorem. And you get B. Say your word. But whatever. Okay. And so. Today, we are going to look at finding the volume of a solid with a known cross-section. While you're writing, I'm going to get out some images of what we're doing. Got a few things to look at. Lots of visual aids for today. Go in my printing box and I will check it. So what does an integral do? Someone remind me what an integral does. Area under a curve. What's the integral symbol come from? A sum. Does everyone agree? So an integral is a big sum, right? Everyone agree? So, what we would like to do is be able to find volumes of things that you haven't been able to find volumes of before. Things that are oddly shaped. oddly shaped solids. But the thing that all of these solids have in common are that the cross sections are things that we can find the area of. So like today we're going to look at things with cross sections of squares. And what would the cross section of this be?
It would be
A triangle, which I'll pass around so you can see that. I got another one with some squares in it. So if I could find the area of each individual cross section, could we add up all those teeny tiny area volume pieces? Yes? That's going to be the goal for the day. I'm going to pass these around. Look at those. So to find the volume of a solid with a known cross section, we're going to write the area formula of the cross section first of all. We're going to find the area of just a piece of it. If the cross section is perpendicular to the x-axis, we're going to integrate with respect to x, and I'll show you in a picture why that is. We're going to be adding up a bunch of volumes of boxes or triangular prisms or whatever the shapes may be with a little tiny dx piece as the width. If the cross section is perpendicular to the y-axis, we will integrate with respect to y. Using the given function, we will have to write an area formula for each individual cross section. That could be in terms of x or it could be in terms of y depending on the problem. And then using the correct limits, we're going to integrate the area formula to get the volume of the solid. So what's happening here? What number are y'all on the top? 40. So we have a solid that has a base of the curve 2 sine of x, and each cross section is perpendicular to the x-axis. The cross sections are semicircles with a diameter that runs from the x-axis to the curve. Find the volume of the solid. Okay. Half of the battle here is being able to visualize the image. If you can visualize it, then you can figure out the area of the curve and integrate. So I'm going to do my best to help you today. So what's happening here is we have a sine function. All the way across this sine function, we have semicircles coming out of it, making a solid figure. Different size semicircles because they're the base of that solid. So you can see how it's working, coming out at us off of the picture. There's an attempt to draw it. It's tough to draw a three-dimensional picture. picture in 2 dimensions. So I've got this, pulling it out. My magnets, let's use your imagination. So we have our solid coming off of this curve. We are perpendicular to the x-axis. So the little widths of these pieces, and you can see they actually have a little bit of a width because they're this bone piece of material. That little width is the change in x from here to here. Everyone agree? So on this particular picture, I'm going to be adding up little dx areas or volumes. Well, adding up areas to get volumes. So I'm going to find the volume of this little semicircle prism, right? So now I want to integrate with dx. And I always want to integrate the area curve, the area function. So I want to find the area of each of those pieces. And I want to integrate it from endpoint to endpoint. So this is sine of x. Where is my endpoint to endpoint on 2 sine of x? Or sine of x. 0 and a pi, right? Which should be the same if I change the amplitude to 2. I'm going to change the 2 sine of x. So what would the area of each individual cross section be? And 1/2 pi r squared. Everyone agree? Okay. Why the 1/2? Where'd the 1/2 come from? Systemizing. Any questions so far? What is r? Okay, is it the y value? I like y. Y is good. Why would it be half of y? Because wouldn't you agree that y value is the diameter of this circle? Okay? So it would only be half of the y value. Everyone agree? What is the y value? On any piece, anywhere I wanted to find the y value, what's the y value? 2 sine of x. But Logan said that I needed only half of it, right? Okay, any questions about that so far?
Oh, you're talking exact height, or you're determining like how big, how?
Okay, it's a semicircle. What's easier? Right? So, yes, though it would be the same radius both ways, we want it to be as easy as possible. Does that make sense? But we gotta use something we know. And so we don't know. I mean, we do because we know the height of the curve. Any questions so far? Can you integrate sine squared by n? Yes. No. So what kind of problem is this from here? Calculator problem. Do that for me.
Think if I can.
Soon we can do sine squared by n. But that is a BC calculus topic. Do what? Good? No? Calculator?
Okay.
It didn't give us units, but do pay attention.
That'll be next piece.
need to get your hand. It was a good try. They're cut. I think I have to.
You're in degrees!
Physics.
Yeah.
Physics. What do we get? 2.467. And this problem did not give us units, but Joseph made a good point. If we did have units, this would be a cubic units, right? Because we are volume. Okay, what's the next one? So you try to set this one up. We're going to integrate the area function. Get it?
We put it if we didn't get it.
And I'm going to talk about it. And you're welcome to take it. So it says a base. That volume of the solid base is a x-axis. And the cross section perpendicular to the x-axis are squares. So they're not triangles.
This king.
Oh.
I just decided about getting this feed. Like, I'm not done. I'm.
Oh,
Okay.
Okay, so this is the image we have. Again, if you can get this image in your head, these problems are a lot easier. If you can't get this image in your head, these problems are a lot tougher. So if you can visualize that shape popping out. Okay, find the volume of the solid whose base is that region and the perpendicular to the x-axis, cross sections coming out that are squares. So we have manifest 3D drawing here again. Square popping out of that, right? So see the board over there for what it really would look like. The squares are not the same size, right? The base of them is going to change as we go along the curve, right? So you can see the image is going to look something like this. Area. Scared. So, what are we going to integrate?
The interval from 0 to pi sine x squared.
Like that.
And then squared.
Pi squared. The area of a square is side squared, right? Side times side or side squared. So does this negative 1, right? So, yeah, you can pull the negative out of 4 if you want. You get negative 1 minus 1. Okay, any questions about this? I don't know. I think this is rotating graphics today.
This negative one comes here.
Okay, so let's do this one. Okay, set up, but do not evaluate. So we're not going to do integrals, although I'm kind of hesitant. It sounds like telling me the integral practice. An integral to represent the volume of the solid whose base is the region bounded by the square root of x and x squared with the indicated cross sections. That's the first thing I need to do. Okay, I'm going to need the intersection, so I can do that first. Is 1 and 0. You can do that by hand, can't you? Or you can use a calculator, but this one can be done by hand. Square root of x equals x squared. Correct? Square both sides. Now, where do I go from there? A lot of you missed this. So you would get the 1 that way. Subtract the x over and factor. That's how you would get the 0 and the 1. You would actually get 4 minus x equals 0. Right, although on this one you don't get it. X equals 0 and x cubed equals 1, which happens at x equals 1. So you can do that by hand. That will help us for most of this problem. We can try to use those for balance. So this is at 0 and this is at x equals 1. Now, okay, I need to find, I'm making squares, right? Along this. So I need to find the area of those squares. So I need the base of the squares. And Ashton said I need to subtract. Why do I need to subtract? Okay, I need this little width here, don't I? This distance, which I can get by doing top curve minus bottom curve. We kind of learned that on Friday, that would give us that width. Everyone agree? So I can get this base, I'm just going to call it B for right now, would be, what's the top curve? Square root of x. What's the bottom curve? So that distance is the base of those squares. Does everyone agree? What do you mean both of those squares? And in parentheses, right? That's what you meant to do. But you couldn't distribute the square, right? Now you could, if we were to do this interval, you had to do it by hand. You could FOIL that out. Do I have to do it for this problem? It said set up but do not solve. There will be some AP game that asks you to do that. But just say set it up but don't solve. Okay, any questions about that one? Good? Okay, I'm going to erase that one. Erase all my work up there. It will be on video if you use it. Okay, now we're going to do isosceles right triangles perpendicular to the y-axis. So this is the first time we've seen one perpendicular to the y-axis. Give me this. So we're making a triangle perpendicular to the y-axis. Okay, now it looks scarier, but what did those steps at the beginning tell us we're going to do differently? We're going to be integrating with dy, which means we want all of our curves to be x equals y, just like yesterday. And so I'm going to change these equations. Instead of y equals the square root of x, what would I change that to? Good. Y squared equals x. And what about the other one? Square root of y equals x. Any questions so far? Since we are doing dy, as soon as you reach perpendicular to the y-axis, you know you're doing dy. What about the limits? Are they still 0 to 1? Maybe. And how am I going to check that out? They need to be the y values. Now, in this particular problem, it is saying that I want to highlight the importance of those may be different because we are dy, not dx. So I would take that 0 value that I got as my intersection of x, plug it in, and make sure the y value is the same. For this particular problem, we are still integrating from 0 to 1, but those are now y values. So I'm going to put a little note here that says those are now y value intersections, not x value intersections.
So was this like the one that we had to like
That, yes, where we said, okay, now we're going to go, instead of top to bottom, what are we going to do this time? And good, right's the positive, left is the negative, so we're going to go right minus left. But what's that going to give us? What is right minus left going to give us? Which, we can go ahead and write that, but which one is the right-hand function? The square root of y, the x squared, which is the square root of y. And what is the left-hand function? Y squared. Okay, that's great. How does that give me area? What is the area of a right triangle? 1/2 base times height. What's important in the wording here, though? Isosceles. What does that mean? That's the same. So base and height are the same, right?
Yeah, put this in the box.
You got it?
Yeah, that's it.
So base times base or base squared. Everyone agree? So my area of that isosceles right triangle is 1/2 base squared. Questions so far? And what is the base? That thing, right? So it's up to you where you put the 1/2. You can move it out front. It's a constant. Just for integration simplicity. Or you can put it there either way. 1/2 base Check again. Look through everybody. Yes.
Oh yeah, we did it right there.
Yeah, because we divided by 2 and fucking filled that out. And I purposefully did not cancel those 2 out so that you would see that too. Wow. Once you've already done one perpendicular to the y-axis and one perpendicular to the x-axis, it saves you a little time, doesn't it? What do I not have to find again? I don't have to find the intersections again. And I don't have to find the base again. I already know what the base is. I just need to see it with my picture. So I'm going to erase the green word. And now we are doing semicircles perpendicular to the x-axis. So this is a different picture, but these would be your y-axis. These would be this way, right? So we're pulling semicircles out this way. So looks like that. We are integrating from 0 to 1, still dy. And what is the area of a semicircle? Okay. So it might not hurt you to do a side note. So what's the area of a semicircle? And what is the radius of one of these semicircles? One half of the base. Be careful, most people who mess up semicircles mess them up right there. They remember this half, but forget to find the radius instead of the diameter. So it is 1/2 pi times the radius, which is half of the square root of y minus y squared. Everyone agree with that? And you can put the 1/2 pi out here, or you can put it in there. It's constant. It doesn't matter either way. Y, the square root of y minus y squared over 2 squared. Did that make sense? Oh, okay, cool. Okay. Any questions on part C? You've seen a few of them already, so that's definitely helpful. Okay, any questions before we go to the next one? If it were me doing it, I would FOIL the top out, get that into, make it a polynomial. I'd probably take the, 2 squared is 4, I'd probably pull that 1/4 out, make it 1/8 pi, and then I would FOIL this out, and then it would just be powerful the whole way. There are a lot of little differences in there you could do, but it would be a powerful problem the whole way. Rectangles with a height equal to 4 times the base, perpendicular to the x-axis. As soon as I read that, you have a mental note, or dx is perpendicular to the x-axis. 0 to 1, go up, I'm going to erase. Rectangles, the height is 4 times the base, perpendicular to the x-axis. So I'm cutting, I've got a little dx width. so everyone agree? Or 4b squared. And what is b if I'm dx? The square root of x minus x squared. Any questions so far? Yes, I can. How far? Any questions about this so far?